If you want to see how I changed this into this, then you'll need to watch till the end of the video. No, not another development board, not another ESP32. Well, yes. I found this recently advertised on my favourite Chinese emporium, and one of the unique things about this is that it has a LoRa chip on it, this little guy here. Now LoRa is a trademark of the Semtech company and is essentially low power, long range radio frequency device for specifically the Internet of Things, for maybe data logging or tracking. So very long range, kilometers of range allegedly. We're going to be testing that. And as well as the LoRa chip, which strangely, I don't know if we can see, there's nothing to see. There are no numbers on the chip here, but it is allegedly an SX1276, and as always there'll be links down in the description to websites and other good stuff. So ESP32, that's not a surprise. Onboard 32 megs of flash, and there's the little Wi-Fi antenna. It has a lithium-ion battery charging circuit and comes with a little lead, so we can see that they've obviously thought about this. And being a development board, we have the header connectors there. One point to mention is that it's very important to make sure the antenna is connected before you power the unit up, otherwise you could damage the transceiver part of it. Now, the other interesting features, it has an onboard OLED display so that we can see messages that are sent between devices. This is the little antenna connector, 2 buttons for programming and reset, and a USB port. Now obviously I bought these as a pair, as we'll be using them as a receive and a transmit. One little mystery here. What is all this about TTGO or TTGO? I've never found an adequate description of this, whether it's Teen Titans Go perhaps, or Talking to George Orwell, or Time to Get Online. Absolutely no idea. If somebody can enlighten me, please leave a comment. So the next thing to do will be to get this hooked up to a PC and install the appropriate Arduino IDE environment and see what it can do. Before we can use our device in anger, we need to install the appropriate libraries, and the first one is the Arduino ESP32 library. Now I'm not going to go through this in great detail, but suffice it to say, once that's installed, we can then test that the board is basically functioning. With the appropriate files installed, now if we go to the Files menu and look at the examples, it will have installed examples for the Wi-Fi LoRa board. And for example, simply we can go to the Wi-Fi tab, for example. I've loaded already the Wi-Fi scan sketch. So all that this does is to scan the local area for any networks access points that it can find and put them up in the serial monitor. So this is just to prove the connectivity. If I now plug in the board, remembering to have connected the antenna for the radio link as well, although we're not using that at this moment in time. There's a little blip there to say that it's now connected, and in our tools menu it's already set up for the correct board. You just choose that in the menu, and also it appears on COM5 in this particular example. If we now go to the serial monitor, we can see that the board is working. So there's just 3 local networks there. And in addition, if we press the reset button on the board itself, we get this little diagnostic, tells us it's power restarted and some other goodness. So now that we've proven that we can communicate with the board at a basic level, the next stage will be to install the appropriate libraries for the OLED. On the supplier's website, this example is quoted, and I've copied and pasted this into the Arduino sketch window. When I tried to compile this, it failed dismally for a couple of reasons. There were the includes that had nothing to include, so they've been removed. You obviously need to include the LoRa libraries. This line is okay with the OLED, but the images file caused a problem as well. In the OLED libraries that I included, there is no images file, which I guess is only for putting up a logo or something like that. So I've commented that out. The rest of it is exactly as per the example. I've already uploaded this now to the unit itself. So here we can see the unit sending its packets. We get the blue LED flashing at the same time as per in the sketch. So the next challenge will be to get the receiver side of the code installed and see if we're actually going to receive anything. Here in the Arduino sketch window is the receiver code. Now, I tried the receiver code that's from the Chinese website, and it just didn't compile correctly. There were so many errors in it, it was untrue for such a small sketch. And in the end I gave up and found a different version which is virtually identical. The main advantage to it is that it works. So having uploaded that to the second board that I have, we can see that it's receiving the packets. It gives you the number of bytes received and also the incremental counter. So it's packet 327 just came in there. Where the hello comes from, I've no idea, but happy days. What is really disappointing is the RSSI at a minus 125 odd dB when the things are virtually next to each other in the same room, and it's extremely disappointing. And I do note that on the Chinese provider's website, that theirs, which appear to be side by side, are minus 85. Quite what the problem is I don't know, whether it's the particular antennas that are supplied or something else. That will be the subject of other investigation, but suffice it to say that we're not going to be getting kilometers of range anytime soon. Enjoy. So here we can see a much more respectable value for the RSSI of minus 19, which is exactly, more or less exactly what we expect. And you can see the packet count going up in sequence there. And the trick was just a change in the send and receive code. As we can see here, where it sets the frequency for the LoRa module, this must be set to 868E6, not just 868. The E6 obviously signifying an exponential to the power of 10 of 6 being a million, so 868 megahertz. And that fixes it. In the next video we'll be taking it out and about and doing some range testing.